Hello everyone, this is James Shore with Let's Code Test-Driven JavaScript. You're watching the lab, which is where we explore, experiment, and generally mess about. And today in the lab, we are finishing up our three-part review of AngularJS, the very popular front-end framework from Google for single-page applications. As I said, this is a three-part series. In the first part, we looked at what it takes to get Angular up and running. In the second part, we looked at value objects and rendering information. And in this episode, we're going to be looking at custom form fields, events, and cross-application communication. I have several chapters prepared for you. First off, we're going to just start with a review of what we've done so far, and then we're going to look at custom form fields. From there, we're going to look at cross-directive communication and how it works with persistent, and then move on to cross-application communication. We'll look at live updating, and then tie it all together, review the entire application before concluding with my recommendations. As always, source code for the application developed in these episodes is available at the link on your screen. Thank you very much for watching, and welcome to the lab. Before we get started, let's take a quick look at what we've done so far. What we are doing in this series is we are reviewing AngularJS and exploring how it works by building an actual application. Specifically, the application that we're building is a re-implementation of a financial projection app that I built in Java many years ago and have been using for this exploration of all front-end tools. So I've also used this exact same application and code base for the React review that we did before this AngularJS review. The application looks like this. It's takes some basic starting information and projects it over the course of many years to tell you how much money you'll have when you die. The actual details of how the app works is not so important. What's important here is, or what's relevant here, is that this is sort of classic front-end app material in that it's very responsive to what you type and it's doing calculations on the client. And it's also interesting because it's a little bit more complex than your typical to-do app. Most notably is it uses Ward Cunningham's checks patterns in the way it thinks about the domain and the way it deals with value objects. All of the things that you type in here are converted to value objects right away. That's an object that understands not just what string has been typed in, but what it means in the context of the domain. In this case, it knows that this is a dollar and that this specific kind of dollar is invalid. The UI then has to render these value objects appropriately. The checks pattern language is very interesting, so check it out if you haven't already. So this is what we are re-implementing, and so far in the last episode, we got all the way to the point of implementing the table, but we haven't implemented any of this code here. That's what we're going to work on in this episode. Now, what we're doing as we review Angular, partly we're building this application just to explore what Angular can do, but we are also looking at it with a critical eye to judge whether or not it's worth using. There are a lot of front-end frameworks out there. Which ones are good? Angular is popular, but that doesn't mean it's good. So we are looking at 5 common pitfalls: lock-in, opinionated architecture, accidental complexity, poor testability, and search engine incompatibility or inability to render on the server side. Lock-in is bad because it means that when you change to a different framework, you lose your investment. And opinionated architecture is bad because the architecture that the framework assumes is not necessarily the one that's best for your application. And an opinionated architecture will make your way of doing things difficult. Accidental complexity is bad because you will spend more time fighting the framework than actually focusing on your problem. Poor testability is bad because, well, this is Let's Code Test-Driven JavaScript. We like testability. Don't we? Yes, we do. And search engine incompatibility, well, that should be pretty obvious, but server-side rendering is also important because that has a lot to do with latency, or basically perceived performance of page load. So you do want the ability to run your application on the server. Most front-end frameworks can't do that. So this is what we have built so far. See the last episode for the details of how that works, but for a really quick run through, what we have is we've brought over all of our domain, persistence, and value logic directly transpiled from the Java version. This is the exact same code that was used in the React review as well, and we're not going to change it. The only thing that we've built custom to Angular is here in the UI package and also up here at the root. The way this works is our index.html is our Angular template. It's got 2 directives in it: a configuration panel, that's this, and a stock market table. That's this. The stock market table in turn contains a stock market row and the rows contain stock market cells. Each of those directives are hooked into our domain model and know how to render value objects using this render function right here. And again, for details on how that works, check out the previous episode. What we're going to do in this episode is wrap this up. We are going to implement these form fields right now, which are just do nothing placeholder HTML. We're going to wrap that up, get everything hooked up, and also make sure that changes here affect the table. So that's what we're going to do. Thanks for joining me. Let's get started. What we need to do now is take these configuration fields and make them actually respond to user input. Right now, it's just hard-coded data. What I want to do is have this respond to our input just like the Java application does. So if I bring that up here, you can see that as I make changes, we get a note about whether or not the user input is any good. So I want to see the same thing happen here. Now, this is very similar to the work we've done in the table, except that now we need it to listen for events on the field, and more difficultly, we need to be able to test it. And interestingly about Angular, the Angular developers make a big deal about testing. They really care about testing. But the way they talk about testing is, in my opinion, it's a little bit shallow. I'm not saying they are shallow, but what I'm saying is that they are using a very popular approach to testing that leads to shallow tests, which is all oriented around dependency injection. Dependency injection is when you tell a class or some function to use its dependency. You basically say, here's an instance variable, run your methods or functions on this instance variable rather than on the real ones or on the regular ones you would do. And when you do that in a test, it allows you to test something in isolation. So for example, we could test our configuration field directive by injecting a fake scope and a fake element. The problem with that is that now you're no longer testing the real thing. And in particular, in the context of Angular, they're doing this dependency injection so that you can test the logic of your directive. But it's my opinion that having logic in your UI is actually a design smell. It's an architectural problem. And in this application, in the stock market projection, we have all of our application logic in the domain model and in the value objects. The UI itself isn't actually supposed to have any logic at all. For example, the decision of whether or not to display this in red, the UI determines how to display it in red, but the decision of whether or not it is red or if it's invalid and needs an exclamation mark is handled by the value objects, by the domain layer. You saw that in the last episode when we were implementing the stock market cell. The UI actually doesn't do a lot. It just says, hey, value object, tell me how to render myself. And then it takes information like, are we negative? Are we invalid? What's the text supposed to be? So dependency injection for testing logic in the UI, I think, is solving a problem that you actually shouldn't have. Your UI should not have any logic except logic around how you handle events and deal with UI-related things. The problem with this is that Angular is not designed to test events in directives. It's only designed, as far as I can tell, it's only designed to inject things into the controller and test controller logic, which is not really the interesting thing here. So we may end up struggling with testing this directive because we've already got tests of all the logic. What we need to test here is that the directive renders properly when we make a change in the field. So I'm really looking forward to seeing how this plays out. I think this will tell us a lot about how AngularJS's opinionated architecture. One of the areas it's really opinionated about is about how it does testing and dependency injection, and its opinions are different than what we're trying to do here. So if we can test this successfully, I think that will be really good and will tell us something good about Angular. If we can't, it tells us that maybe Angular is too opinionated in this area. The first thing I want to do, though, is just factor these modules out into their own files and start tests around them. It's going to be exactly like we did for the stock market cell, row, and table. So I'm going to go ahead and do that off camera, and we'll be back in a moment. Okay, I've got the configuration field factored out, and I've built a little do-nothing test, just copied in the boilerplate from our stock market cell test. Now the question is, how do we want to approach this? The basics of just typing stuff in works very simply. So how do I want to approach this? What do I want to test? I guess there's two things that I want. One, I want the configuration field I want it to store the user's input in the scope, I guess. And that's really just a stepping stone to the scope. It changes the scope when the user input changes. And that is also just a stepping stone towards we want it to display the warning icon when a bad value is input. But this right here feels like too big of a step. So let me sneak up on it with these other two tests. I think a lot of the work here is going to be actually writing the test, not so much in the production code. As per usual for new technology that I'm testing for the first time, I spend more time figuring out how to test it than I actually spend with the technology in a lot of cases. But then, as always, once I know how to test it, then that investment has been made. Anyway, I think sneaking up on it in this way will let us figure out the test aspect of it, and then we may delete some of these initial tests and just keep the important one that we need here. I don't think there's a whole lot more that a field needs to do other than display this warning icon or not, depending on what's entered. Okay, so the question is, how do we deal with that scope? How do we tell that the user's input is stored in the scope? Well, actually, let's go back even one step further. Because again, I think the input events are going to be the hard part here. Let's go back one step further and say it defaults to an initial value. Yeah, that will let us sneak up on this even more easily. So if we look at our stock market sell test, we can see that we set up a parent scope so that we can pass in values. That's basically what we want to do here. We want to be able to say configuration field value equals whatever. So let's go ahead and actually put that in. Our test HTML in this case is going to be configuration field value equals something. We'll call it initial value. And then we're going to want a title, and then that's the end of the configuration field. And the way we want this to render is with the title as a bit of text and then a configuration field. And we could even test that. I'm not sure if we want to, though. It's kind of clunky and doesn't add a lot of value. So if this is what we're testing, we'll need to set up this initial value. And we can do that in the same way we did here in the stock market test by creating a parent scope by calling root_scope.new. This is the parent scope for the configuration field. And then setting that initial value to a new user entered dollars. In this case, let's say 123. And what we should expect is that the configuration field scope should have a value that equals that initial value. So we're going to get the value, but not only that, we should probably also expect that the field renders with the initial value. And in fact, that is probably more important than checking the value on the scope, because that value on the scope is kind of internal data. But let's start with this. So I'll finish getting this set up. We'll need to compile the HTML with that parent scope, digest it, and then find our element. Or in this case, let's start out by getting the scope out of our element and seeing what we get. Now, I think this test will run, and I think it should fail appropriately. I'm assuming that our value here will be undefined, and our initial value will be the user entered $123. Let's go ahead and try that, see what happens. Yeah, that's exactly what we're getting. We're expecting undefined to equal user text 123. Now, if I simply, in the controller, define our value as foo, we should now see that comparison say expected foo to equals whatever. And it does. Which means that I could tell Angular to set the value, to link the value to, well, the value field, which I'll go ahead and say twice, although you could also just do this, but for now I'm going to be more explicit about it. And that works. But this is not really what we want. What we really want, we don't care about the scope, as I said before. What we really want is to expect that the element's input field has a particular value. So let's go ahead and get that element out, that input field out. And what is it called? It's called input, and it's the only one there is. So let's expect the value attribute to be 1, 2, 3. The field should reflect exactly what the user typed in. It doesn't convert it to a dollar amount like we do in the, here we format everything with commas and so forth. Here we just put in exactly what the user typed. So we should expect the value to be 1, 2, 3. And I'm going to expect that test to fail. Again, I should, in this case, I think it'll either maybe undefined or it may be blank. Looks like it's undefined. If I hard code that, now we should see expected bar to equal 1, 2, 3, and it does. And unless I've made a silly mistake, which I might have, we should now also see bar show up here. And we do. Now the question is, how do we connect this? Well, one simple way would be to just connect it to our scope like that. That's not the Angular way. As Will Pinnell mentioned in the live stream chat, the appropriate way is to use ngModel. But I'm sneaking up on this here. So let's see if this works. And now because this isn't the Angular way, it may not actually work. Let's see what happens. Well, it kind of worked. It converted it to, it dumped it to the object string. So maybe what we need to do is say value.toString. Will that work? I'm not sure. Oh, it is kind of working. Yeah, it's working. We called toString on it, but the problem is that that converted it to the actual string. So now let's call a render function. And we'll set that up in our controller. And that will return the values underlying user entered dollars. And I think this will work. And it does. And when we run it, I think the code will fail because we're not hooking up that value. Yeah. Wow. It really fails. But that's okay. That's just fine. It's just because we haven't done the work inside of configuration panel to connect to configuration field correctly. And when we test drive configuration panel, we'll make that work. So this works. It gets us started on our configuration field test. It's not very Angularly. Typically, you'd want to use ngModel. So I'm going to take a moment to research this, see if there's a better way to do this. Back in a few. I've talked this problem over with the folks in the live stream chat when I recorded this video. So thanks very much to Martin Grondroth, Will Pinnell, and Scott Corrigan for their contributions. And there were some various ideas tossed around about how we could make this more Angularized. The most popular one was to use a filter. In Angular expressions, you can put in a pipe and then the name of a filter. And I'm not entirely sure how that works. And that filter will transform an object to a string for you. So that is something that might be a good fit for us. The problem is, and the one thing I'm not sure about there is that for us, we're not just dealing with converting an object to a string, but we're dealing with a whole rich field. So we need to know not just convert to a string, but we also need to figure out what kind of warning icon to put here. And in the future, these tooltips could even be dynamic. So we have three things. We've got the text, the icon, and the tooltip. So what I think I'm going to do next is go ahead and get the rest of that rendering in, and then take a second look at how we can angularize it. So far, my sense is that we're just going to end up doing this very similarly to the way that we've did the stock market sell. So I'm going to go ahead and get that in. Let's now talk about how it renders. So it renders, we want it to render invalid values with a warning icon. So we're going to do the same thing that we did here. In fact, we might want to factor that out, but I'll do that later. Doing all the same stuff, except now let's pass in an invalid amount. We'll still expect the value to be exactly what the user typed in. So that should work just fine. But we also expect the whole element to be rendered with the invalid class. If you look at the actual HTML here, the way this is rendered, it's rendered with an invalid class on the input field. So let's look for that. We're going to expect the input field to have a class of invalid. Now, Angular does have the ability to validate a field. You can write a validator and it will put its own ng invalid on it, I believe. Again, that's a little bit more complexity, and I don't know if it's going to add a lot of value. Since this code is very much specific to this directive, there's no need to reuse a validator. So I'm going to start out by just doing it myself, and then we'll look at the question of whether or not moving to an Angular validator would be beneficial. And once I remove that invalid class that's hard-coded, now the test should fail. Yeah. So what we need to do here is we need to have this render function work a little bit differently. For now, I think what I'm going to do, let's go ahead and comment out this invalid test. I'm going to refactor it. I think we can just start out by having our controller set the rendered text to the user text. And here we can put in the rendered text. And I'm hoping that that will work just fine. It won't respond to changes, but we're not making any changes yet, so that's okay. Yeah. Now let's bring in this invalid class, and we'll see this test fail now. So now what we need to do is say it's invalid, well, based on something. And what do we want it to be based on? Let's just hard code it for now. And here what we'll do is we'll set the class. And I think there is an Angular directive that will set the class based on a Boolean in our scope. So let me go look that up real quick. Okay, it looks like ng class works a little differently than I thought. What we need to do is put the class name in a variable. So what I'll do is I'll say invalid class. And for now, I'll just hard code it to invalid. And then here I'll say ng class equals the name of the variable, which in this case is invalid class. And ng class will figure out that, or knows that this means put in the value. Now I think this is a little bit, it's very inconsistent here. In one place we're saying evaluate what's in the value and put it in directly. Here we're saying use the string. I can see why they're doing this. This is a directive and this is just an attribute. But it's another case of, I think, where Angular has got some inconsistency that doesn't make sense unless you really understand what's going on inside of Angular. And let's just to make sure we're not doing something dumb, let me replace it. And we should see expected invalid, but got XXX or whatever. Oh, well, expected false equal true because the class doesn't exist. Good. All right, now that we have this working, we are starting to sneak up on this. What I'd like to do now is refactor this to use the self-rendering objects. So if you recall, all of our value objects know how to render themselves, and what we do is we ask the value to render itself to a render target that we will implement here in our UI. So I'd like to flip this code around to work in that way, and it's going to be very similar to what we did for the stock market cell. So I'm going to go ahead and do that, and I'll be back in a moment. Okay, I've gone ahead and implement the render target. It worked very similar to the stock market cell. Again, we create a new render target, which is just a little class that we've defined here. In this case, we're passing in the scope rather than the element because in this particular case, we're not manipulating the element directly. Instead, we tell the value to render itself to the target, and then it changes things in the scope so that this template works correctly. And I feel like this is a little bit more Angularized than manipulating the DOM. Everything I've read says try not to manipulate the DOM in Angular. So I like this a little bit better. And I've also implemented some dummy data in our configuration panel so we can see that this actually is working. But obviously, it's not hooked up yet. So I think that's the next thing to do. We want to see this value change when the user input changes. So let's go ahead and do that. We're going to change the rendering. It changes the rendering when user input changes. Now we know the value is going to change automatically, but we want to see it flip back and forth from valid to invalid. So let me grab this boilerplate and we'll expect invalid to be false. And we'll need our input field. And then we need to do something to cause the input to change. And this, according to my research, is not something that Angular really has a clean way of doing. So we're going to have to figure that out. And then after that, the invalid field should be true. So I'm going to go ahead and figure out how to programmatically trigger that input change in our test, and we'll be back in a moment. All right, I am back, and it is working now. Whenever we change the value of the field, the form is, or the value is validated, and we get our custom icon. Doing this was not so bad, except for a couple of dumb mistakes on my part that I won't go into. What I did was I switched over from setting the value of the input field directly to binding it to the ng model. The ng model directive basically says put whatever value is in the input field into the rendered text variable on the scope, and put whatever's in the rendered text variable on the scope into the input field. This is exactly Angular's famous two-way binding. So testing this was not so bad. I didn't have to worry about input events at all. Thank you very much to Martin Grandroth on the live stream chat for that suggestion. It worked out really well. We have our boilerplate here, which I really need to factor out. Then we just get the isolate scope for the element. We change the rendered text to something else, have Angular digest it, and then we can say, hey, now the invalid class is there. The way this works in the actual code is pretty ugly, and I'm going to look for ways to improve it. But what we do right now is we render everything when we start, and then we listen for changes to the rendered text, because this will change whenever the value of the input text, the input field changes. And when it changes, we re-render. We create the new value for the field and then render it out. Okay, I've made some minor improvements to the test, mostly just taking out all the duplicated logic. Now it's factored out into a create field method. I also added a test to make sure that the field would update when the parent scope's value changed, just like we did for the stock market sell test. There's no big change there. And I had to modify our configuration field code to watch for changes to that parent value and re-render. This code is, I think it's okay. It's not amazing, but it's okay. And with that, we've got everything working the way we want it to. Our configuration panel does change when a user, it does render itself according to the user's input, and it is able to change and track that value. What we don't have working yet is communication between what's going on here in our configuration panel and what's going on here in the table. And that is a question of cross-application communication. In order to get our configuration panel talking to our stock market table, we need to deal with a new aspect of the architecture that we've ported from Java, and that's this persistence layer. All of the user data is persisted to the server. Well, it's not really. It's a simulated persistence layer. But theoretically, all of our user data is persisted to the server in this user configuration object. In the Java application, this actually handled file saving and restores. If we were writing a real app here, this would talk to the server and give us information back. But this right here, this is the central point of coordination between the various parts of our application. So what we need is for this configuration panel to store the individual fields into that user configuration. And then what we need to do is, when that changes, update this table. So the first thing we need to do is just set up our configuration panel to use a user configuration object. That should be pretty straightforward. I'm going to go ahead and do that and be back in a moment. Okay, here's our configuration panel. I've got it set up with the same kind of testing that we have in other places. It's got 3 fields, and it initializes those fields from the user configuration. And if we update the user configuration, then it also updates. The actual code for this, just like you've seen before, we're watching the configuration and then copying data out of the configuration into the scope and using that to pass through to our configuration fields. Pretty straightforward. Now this gets the data from the user configuration into the fields, but it doesn't get the information from the fields back into the user configuration. And due to the way Angular works, I'm afraid that this might be a little bit complicated. And let me see if I can explain this. Angular has the concept of a scope, and the scope is it's a prototypally inherited object that starts at the root scope and then nests down through your directives. Now, prototypal inheritance was probably a poor design choice on Angular's parts, because what it gives them is it gives you the ability to automatically see what's in your parent scope. But prototypal inheritance only goes up the prototype chain. It only goes up to previous scopes when you read. When you write to an object, it writes to whatever the bottommost object of the chain is. When you read, it looks up the prototype chain, but when you write, it writes just to the object you're talking about. And for more information about this, see the Definitive Guide to Object-Oriented Programming. This lesson's learned right here. What that means is that you have to be really careful about how you choose to read and write to scope in Angular. If you write a variable, an object reference, a string, a number, that's going to be written to your scope, to the bottommost thing. And this is really hard to explain. And there's a bazillion articles online about this, because it's, in my opinion, it's one of the architectural flaws of Angular. Basically, what I'm saying here is that in our configuration field, when we change the value and we create a new user enter dollars and write it to our scope, and we have to do that because user enter dollars and all of our value objects are immutable. When we do that, that writes to the configuration field scope, and it does not get bound back to our configuration panel because we are creating a new object reference. If we want our configuration panel to see the changes that we've made in configuration field, we actually have to put it inside of something that already exists. What we'd have to do is create some sort of container reference like this, and then put each field inside that container. And then we can pass them through like this. And that will cause the configuration fields to be written to container.startingBalance. Container will already exist. It's an object reference. So when we say, for example, scope.value here, Angular will copy that reference into container.startingBalance here. But we're not going to change the value of container, so we'll still see it. It's really complicated. And I think it's a flaw. I think it's a mistake on Angular's part. Anyway, what I want to do next is I want to write a test that proves that when we change the configuration field, it doesn't show back up in our scope here. And then we'll change the code by using this container to make it work. In order to do that, though, we have to have some way of programmatically changing the configuration field. So what I'm going to do is I'm going to write a little bit of code to give us the ability to change the configuration field from our configuration panel test. Go ahead and do that and be back in a moment. Okay, I've implemented a little set text method. Thanks to Martin Grundroth on the chat for suggesting this be called set text. So set text takes the new text of the field, and then over here we just update the rendered text, and that works great. Now what I'm going to do is I'm going to use that method to modify, to write a test that says that the configuration panel scope updates when the user enters new text. So let's see. I guess what I want to say is that the configuration panel updates the user configuration when user input changes. And specifically, fields 0.isolateScope.setText, and now we can expect that getStartingBalance is foo. Of course, this here needs to be .equal 0, not bracket 0. Bracket 0 gives us the DOM element. This gives us the JQLite element. So let's give that a shot. Okay, there we go. We expected foo, but we got 10,000. We got the original value. So that is failing the way we expect it to. Now what we need to do is to get this, when the field changes, it needs to go back into our scope configuration. And again, the way we need to do that is these values, when they are written, don't show up in our scope because of the way prototypal inheritance works. So we need to create a container object so that when the value changes, it goes into a reference we already have. So here's our container object, and we'll set up our scope, our starting balance to work on that container object, and we'll change this to modify the container object. Right, because here I need to say scope.container. Here we're going to want scope.container.startingBalance. And here we want scope.container.startingBalance. So we've fixed all of our other tests. We still have our user input changes test failing, and I think that's because we're not watching for changes to the container. So what we need to do is we need to watch the container, and we can't just watch the container, we have to actually watch everything in the container. And when anything inside the container changes, it's a shallow watch. Then what we'll do is we will modify the starting balance, set the starting balance to contain the starting balance. And that, I'm thinking, will work. So that is all working now. Next, what I need to do is do the same thing for the remaining fields. So I'm going to do that back in a moment. All right, there we have all three of our fields. Now our user configuration is being updated when any of our configuration panel fields update. What's interesting about this is that we didn't have to do any sort of explicit eventing between our configuration fields and the configuration panel. It's just automatically being put into the container, and then we can watch for changes on that container. It's pretty neat. I think it's one of the reasons people like Angular. The cost of it, though, is really having to understand how these scopes work, and a lot of accidental complexity related to the way the scopes have to connect to each other. If I didn't have this container object, it just flat out doesn't work. So is that complexity worth it? Well, for some people, I think it is, but I have a strong allergy to complexity. So for me, it doesn't really feel like it's worth it. But we do have this working, which means that now our user configuration, which is the fundamental object that we're going to use to coordinate across our application, this is being updated whenever these value changes. The one last thing that we need to do here in our configuration panel, we need these fields to update when the user configuration changes. So we're putting changes into the user configuration, but we also need to see changes to the user configuration go back into the fields. So let's go ahead and write a test for that. It updates user configuration when user input changes. It should also update configuration fields when user configuration changes. And I think the way we can do that, we can count on Angular automatically connecting our starting balance to the field. So all we have to do is make sure that this value right here, all we have to do is make sure that this value right here gets updated when the user configuration changes. So let's say config.set starting balance to, I don't know, 98765. And then we'll digest. And then we'll expect the parent scope .container.startingBalance to equal the new value. Except here it's not supposed to be parent scope. This should actually be our panel's isolate scope .container.startingBalance, because this will get us the actual scope of our configuration panel. Okay, we're expecting 98765, but we're getting 10,000. That's failing as expected. Now what we need to do is we need to get the configuration to update. We need to get changes to the user configuration to be reflected in the container. And there's two ways to do this. First, and perhaps most correct, would be to watch for events on the user configuration. User configuration actually implements the observer pattern, so it's something that is observable. We can basically hook up events to it. But a little uglier, but perhaps more angularly, is we could change our watch here to say watch collection, so that when anything inside the configuration object changes, we'll fire this code. What's happening there is it will change when the private variables inside of user configuration change, which is probably not good form, but it is kind of the way Angular is meant to work, so I'm inclined to try it, at least to start. Let's see if that works. Yeah, it does. That is pretty clean. Let's go ahead and go with that for now. I don't love it, but we've spent a lot of time on this code already, and it demonstrates the principle, so I'm going to go ahead and leave it as is. Okay, and with that, I think we've finished our configuration panel. It's now putting all the values in the configuration fields into the user configuration object and vice versa. Now all we need to do is have changes to that user configuration update our stock market table here. And that should be pretty straightforward because user configuration is observable. It's something that we can trigger events on, or we can listen for events on and do something with those events. So what I'm going to do is I'm going to implement our top level code, our application controller, put tests around it, and then we will write a test that confirms that when the user configuration changes, the stock market table changes. And when we do that, we should be done. I'm going to go ahead and get those tests started, and I'll be back in a moment. Okay, I've got our testing boilerplate working here. Now, testing a controller is a little bit different than testing a directive. What we've been doing up until now is testing directives, but for our example code, for our top level code, this is actually operating as a controller on our index.html template. Now, I could have implemented this as an application directive, and perhaps that would be a better way to do it. I'm not really sure. But in the interest of exploring Angular a little bit further, I decided to do it the way most people would, which is as a controller behind this template, this index.html template. So here's our controller code. Right now it's just hard-coded. We're setting up a stock market projection and an empty user configuration. There's no attempt to hook things up at all. And then in our test, to test this, we do the same sort of boilerplate we do before. We bring in the module, and then we inject a controller service, which we can then ask for our example controller and pass in just a hard-coded scope. In a lot of ways, it's easier to deal with than our directive tests. Once we've done that, we can do whatever we want with the scope. Here, I'm just confirming that the configuration has an empty configuration on it. What I really want to do, though, I want to confirm a couple of things. First, I want to confirm that we do start with an empty configuration and a default projection. So it initializes the configuration with a default value. It should also initialize projection based on configuration. So we'll expect the scope.projection to equal an expected projection. And that expected projection will be, let's do it this way, projection for new user configuration. Or better yet, let's say scope.configuration. And we'll write a little function here, projection for, and that is basically this code here. So I'm going to steal it. Except here we're going to have config.getStartingBalance, config.getStartingCost basis, and then we create the projection with the first year and ending year, and then the yearly spending. Okay, we've required everything. And that's failed. The configurations don't match. Hopefully that's just a matter of making them match. And let's actually, it's going to be the same basic code, which actually tells me that this code should not be here. It should probably be inside of user configuration, but we're not changing any of our design and architecture outside of the UI. So I'm going to just leave it as it is. So pass in that user configuration, and hopefully this will work. And it does. That's just the basics though. Let me make sure I haven't broken anything. Nope, all good, but still not responding. So now what we need to do is we need to write a test that says it updates projection when configuration changes. And because of all the other work we did in our directives, making sure that they responded to changes in properties, once this test passes, our code should just work. Let's go ahead and give it a try. So we'll write a test saying that scope.configuration set starting balance to 1, 2, 3. And we'll expect, we'll need to digest it, I think. I'm not actually sure. Well, for now, actually, I don't think we do. For now, let's just say that we expect the projection to equal the projection for that new scope. And this needs to be a user enter dollars. Let's see what happens. Okay, that's failing. Not in a terribly readable way either, because we've got 40 years inside that object. But that's all right. Now, making this pass should just be a matter of listening for changes in the user configuration. We should be able to say scope.configuration.onChange update the projection. And let's make sure we're using the same configuration for both of these. Actually, let's do it this way. We'll put the configuration first and then have this just be the scope.configuration. And that should work. Now, I should also listen for the controller ending and disconnect the event handler, but for this app, it's not really necessary since we never go to another page. Okay, that's failing because we can't compare our user configuration in the way that we have been. So I'm going to update this test to work a little bit differently. So I've just modified it to look at the individual values because by doing the deep equals as we were, it was seeing that our real configuration had event handlers on it, but our test one didn't. And so that was just an inappropriate comparison. This test should now pass. And it does. So if I've done this right, if I've understood Angular correctly, which I don't know that I do, but because our directives are all programmed to work with the double binding and to automatically update when variables update and so forth, because we've written this to change the projection when the configuration changes, that should be watched for and automatically cause our application to change. So let's go ahead and run it. If I'm right, then we're done. Reload, and there we go. It is all working. Yeah. It's a little slow feeling. People do say that Angular doesn't do well with big tables because of the way the watches work. And it doesn't feel totally crisp. It's not too bad, but it is feeling a little bit slow. So there we have it. Now, if we go into our user configuration and enable the simulated updates from the server here, we should also see the code automatically change as the server updates. Now that's just on a timer, but if we reload it, does it work? Oh no, it doesn't work. It is not updating our values here when we see changes to the user configuration here. Okay, I think I've got this figured out. Thanks very much to Martin Grundroth and Will Pinnell in the live stream chat for helping me figure this out. What's happening here is we are changing the user configuration, but we're not telling Angular that anything's changed. So what we need to do here is say scope.apply and then pass in a function and do our change there. Now, what is that going to do to our tests? I don't know. First, though, let's just see this work. Run that, and we get this digest already in progress problem. It is working. Our code is now live updating just like it's supposed to, but we're running the digest twice. So that's a problem. And to fix that, what we need to do is we need to come into our template here and change this to be and apply async. This basically says make the change later. And I don't know exactly why this works, but I tried it off camera and it does work. So if I rerun this and then reload here, now everything works. And works really well. Everything is doing exactly what it's supposed to. So now we have simulated changes from the server coming back. Now what you're supposed to do is use Angular's services to deal with changes from the server or timeouts or stuff like that. Because we weren't doing that, that's why we had to do this apply async. And that gets back to the question of opinionated architecture. I wanted to see that we could make no changes to the rest of our code, only make changes to the UI to make this work. We can, but it did take a little bit of figuring out. Now this, I think, will break our test because we don't have an apply async on our scope. Remember, our scope is just a fake object. Now I see a couple of options for this. Well, first let's confirm that that's right. So if I run our tests, yeah, boom, everything's breaks. Apply async is not a function. Now I would really prefer that apply async was working. I mean, this code flat out does not work if we don't use apply async. But I don't want to write a test that says, hey, we called apply async. That's not useful. What I want to know is that this actually changes when we make a change to the configuration sort of without calling digest. I guess what we're doing here, apply async is causing digest to be called at some point. On the other hand, I've spent a lot of time with Angular and I am feeling pretty tired of it. So let's take this out, confirm that our tests are still failing, and I'm just going to mock out that apply async. I'm not going to test it because I am feeling pretty done with Angular. And so to do that, we can just put in an apply async with a do nothing function. And this should finally work. And it does. And that does it. We now have a working Angular app. It has not been a fun journey. I have to say, I have cut out a lot of the pain in this episode. I would not choose to use it in my own projects. Before we wrap up though, let me take a quick look at what we've got. So just a reminder about how all of this is fitting together. We start out here in index.html, and this is our Angular template. We tell Angular to make this go by and run example, which is going to end up loading our example module, which we define in example.js, which is loaded here in our Browserify bundle. Inside of example, we depend on configuration panel and stock market table, which informs Angular of these directives and loads them up. And we also set up our controller. This controller actually ended up being, other than this apply async ugliness, which never did get properly tested, other than that, this controller is really nice and clean, and I like how simple it is. There probably should be a destruction, a unsubscription to the change events, but actually the persistence layer doesn't support that, so we didn't put it in. So we set up our configuration, we create the projection, and that automatically, these variables, because of their names, automatically get connected back up over here. This is an example of Angular's strong use of magic strings, where it uses coincidental naming of strings to automatically figure everything out. So our configuration is applied here to our configuration panel. Our projection is applied here to our stock market table. This tells these directives to look in our scope at this stuff. So in our configuration panel, which is defined down here in our configuration panel directive, this says whatever property is in the configuration attribute, that's going to go into our scope and bind them together so that when one changes, we change. We listen for that configuration, watch for changes on it, and whenever it changes, including when it's first created, we get the values out of our user configuration, our starting balance, our starting cost basis, our starting yearly spending, and we apply them to a container object. Another glitchy thing about Angular, it has this beautiful double binding, but it doesn't work when you're dealing with straight values. You really need to have container objects to make it work properly, because you can read from parent scopes, but you cannot write to parent scopes, at least not by default. So what this does is it reads the container, child scopes read this container object and change its contents rather than writing to the scope. It's kind of a brain bender. Again, check out the object-oriented programming video here for more information about how prototypal inheritance works. So we copy the values out of user configuration into this container so that we can set up our configuration fields to look at those starting balance, cost basis, and spending. When those values change, we set them back into the user configuration, which causes our example to see that the configuration has changed and update the projection, which causes this table to change. We're also connecting our stock market cells to the value objects through this render target stuff. That actually came out pretty clean. And we're doing the same thing with our configuration fields here. And that is also reasonably clean as well. There's a lot of watching going on here though, which I'm not particularly thrilled about. Okay, let's wrap this up. Bottom line, should you use Angular? Let's take everything we've done over the last 3 episodes and wrap it up into a bow. Should you use Angular? Well, no. I really don't think you should. It's not very good. But let me explain why, because I know that is going to be actually somewhat controversial of an opinion, because Angular is very popular. So let's look at our review criteria. What we've been looking at over the last 3 episodes for Angular, as with all frameworks, is we're looking for 5 common pitfalls: lock-in, opinionated architecture, accidental complexity, poor testability, and search engine incompatibility and lack of server-side rendering. So how does Angular do on lock-in? Lock-in occurs when changing to a different tool requires you to throw away your existing code. That obviously is not a good thing. You lose your investment. And it's pretty obvious in Angular that that is the case. If we write directives, we are rewriting code that is very, very specific to Angular. This is not code that we can use anywhere else. Also, Angular is a framework. It's not a library. So unlike a library, we can't hide it behind another library that we write ourselves. It's very difficult to abstract a framework. Not only that, so it's not uncommon for a front-end framework to be written in sort of this custom language or frameworky approach that you can't port. Not only that, though, Angular really encourages that you put your client-side logic into Angular concepts. You're supposed to use services. You're supposed to write filters. It wants you to use things like $HTTP. It's HTTP service when you're talking to the server. So really, Angular wants you to put everything on the client side into Angular code. But that code is not portable. If you switch to a different version of Angular, the code is gone. So lock-in is very, very strong with Angular, and as a result, it's an absolute failure when it comes to this pitfall, because anything you write the Angular way is gone when when you have to throw away your Angular code because you're going to something else. And this is particularly relevant because the Angular team has announced version 2.0, which is a complete rewrite, and it's looking like it is going to be incompatible with 1.x, which means that throwing away code and having to redo your work is not so far off. Now, Angular 2, who knows when it's going to come out? It's vaporware right now. It could well be suffering from second system syndrome. That's when people look at their first work and all the mistakes they made in it, and then they try to build something way too complex and it never comes out. You saw this with Perl 6, if any of you follow that. So anyway, lock-in, no, not good. Second pitfall, opinionated architecture. This is when a tool assumes a particular way of structuring your code and punishes you when you try to use a different approach. Angular is designed for a very specific architecture, but it isn't very explicit about it. Let's call it passive-aggressively opinionated architecture. As far as I can tell, and like I said, they're not very explicit about this, but as far as I can tell, Angular assumes a very specific architecture. They assume that you have global objects, which they call services, that contain all of your business logic, and maybe some filters and so forth as well. And then dumb data structures that you put on your scope, and they'll call those models, that contain your business data. And that the data in combination with the services is how stuff gets done. And then there's glue code in each page to connect the models to the services. These are the controllers. And then directives to act as sort of ways of factoring it out or to create components. That's the assumed architecture, really global business logic and dumb local data structures that are objects without any methods on them. This default assumption is not a very good architecture. It's it's conceptually very, very simple, but it has very poor cohesion because your business logic and your data are strongly separated. There's a heavy reliance on globals because their services are singletons. They're effectively globals. You can find them using dependency injection, but that's just a sort of a weird global lookup thing. And I haven't seen this myself because we used a different architecture, but I would expect that this approach would encourage logic to be sort of spaghettified out throughout your system and put in the controllers. The controllers end up as sort of the catch-all logic container in this environment. So I don't think it's a very good architecture. And it is the one that Angular is really designed to support. And that results with some awkwardness. You see it here in configuration panel where we have our logic, which is in a typical architecture with a rich domain model and a persistence layer and value objects. Value objects are a little unusual, but it's still very in line with a classic domain-driven design approach. You can see here how we have to copy our data out of our persistence layer and into scope objects in order for Angular to work with it. That's because our architecture didn't match the implicit architecture that Angular expects. We also see the same thing in stock market row. It's actually in all of our directives, but it's most obvious right here. Again, we have to copy the data out of our domain object and into scope before Angular can work on it. But it was possible. So we didn't do things the Angular way, and it was possible to make the code work. It was just kind of awkward and didn't go very smoothly. Angular's opinionated architecture, it's not a great architecture. It is opinionated, and it doesn't really work with you if you decide to do something else, but it doesn't stop you either. So I'm going to call this sort of a toss-up in terms of whether it's good or bad. Next, accidental complexity. Accidental complexity is time spent fighting with the tool rather than focusing on the problem you're solving, and Angular is terrible in this regard. It is just absolutely terrible. Oh my God, I can't believe how bad it is with regards to accidental complexity. Sorry to vent at you, but I have had so much trouble. I cut most of it out. But overall, I spent 39 and a half hours working on the Angular code. And in comparison, when I did the exact same project in React, we spent just under 29 hours. So we spent 10 hours more in Angular. And in the Angular code, I was using stuff I'd written in React. You know, we solved it once already. It's supposed to be easier the second time. No. Lots and lots and lots of time spent fighting with Angular. It has the feel of a complex system that's grown very awkwardly. And I would say that the biggest flaw with Angular is that in order to understand how to use Angular well, you have to understand how Angular is implemented. That's called a leaky abstraction, and it's a sign of poor design. One of the most obvious ways that you have to understand what's going on with Angular is scope. For example, the introduction of this container object here. Do you understand why we need this? No? Well, it's because of the way Angular has implemented its double binding. And that is one of the most confusing things. But stuff like that is throughout the system. For example, why do we use controller here in this directive and link here in this directive? What's the difference? Why does it matter? When does it matter? In here, why do we use apply? And why is specifically apply async rather than apply? Well, apply async worked, apply didn't. Why not? I still don't know. There's many cases where there are multiple ways of doing things and they have very subtle differences. You can see that with the link versus controller question on directives. But in your regular template controllers, you have the choice of using something called controller as, or just the regular controller we're using here. So we have ng controller equals example controller. We could also say something as example controller. That will behave differently than this approach does and also requires slightly different configuration. We had huge numbers of problems with figuring out how to make testing work, getting everything set up. It's just lots of issues. Angular likes to redefine terms. For example, their approach to dependency injection is not actually a typical approach. It's really, again, just a way of locating a global. They have their own module system. When things fail, they tend to fail silently. They have their own custom language that you use inside of your templates. We didn't really delve too deeply into that, but it's throughout. They have these custom sigils that can mean different things. There's equals, there's ampersand, there's equals star. There's a lot of different little sigils here. Special characters here. There's just complexity after complexity after complexity after complexity in Angular. And I got to tell you, I'm so sick of it. Let's look at testability. Testability is, can we write fast-running targeted unit tests using our off-the-shelf testing tools? In our case, Karma and Mocha, but really anything. And one of the important things here is being able to do unit tests rather than end-to-end tests. You can test just about anything on the web by spinning up a Phantom.js or Selenium test environment and clicking things in the browser, but that's very slow and it's brittle. What I want to see is the ability to unit test. Now, Angular puts a lot of emphasis on testability, so I expected this to be something it was really good at. But sadly, it's not. It actually has very poor support for testing. What it does is it emphasizes testing logic stored in controllers and services. But it actually has pretty much poor to non-existent support for testing the front-end UI and the way the UI behaves and reacts to events. And all this emphasis on testing controllers and services is, in my opinion, a reaction to its poor architecture. It's business logic. They want you to put your business logic in services, which are globals. You can't test a global effectively without doing some sort of dependency injection. So that's what they have it for. But what's even better is to put your business logic in business objects, as we have, that are completely separable from the UI and can be tested separately from the UI. That's what we have. Our domain logic and our value object logic is tested without worrying about Angular at all because it's not implemented with any concern for Angular. So what does that leave us? Well, the only thing that we care about in the UI that we need to test is how does Angular basically display different things at different times in reaction to differences in the domain logic that matter to the UI, and how does it react to events? Neither of those things are things that Angular is designed to test. You are not actually able to test templates at all, and there's no way to trigger events in Angular that actually runs a browser event. There's no way to test events. There's really no way to test components. We can see that here in our configuration panel test. We had to write this very, very clunky check directive where we render out a component, a directive, and look at compare the inner HTML. You can see the code here is just messy, the way we had to do that. The one saving grace for Angular, the reason this doesn't get a frowny face, is that it can be unit tested. They do also offer a custom end-to-end testing tool called Protractor. But again, when I'm looking at testability, I'm looking at unit testability. So Angular is just not very good in this regard. And that's surprising and disappointing considering how much emphasis they put on testability in their documentation. Last pitfall, really common one, server-side rendering. Lack of search engine indexability. Angular cannot be rendered on the server side, and it is not indexable by search engines without doing some ridiculous things with Phantom.js. And so it fails on this regard. This is not uncommon. React does allow you to do server-side index rendering, but it's very unusual in that regard. So bottom line, after spending this time with it and really digging deep, I'm not an expert, but I do feel like I'm informed enough to have an opinion. And I have to say, I am surprised at how popular it is. Now, it pushes a lot of geek buttons. It's built by a team at Google, which of course is, a very big influence on the programming landscape these days. It sort of pushes our buttons. Programmers like things, the sense of mastery. It's nice to feel like I know something that other people don't. So I think maybe the complexity that Angular provides, which I think is a real detriment, is actually part of why people like it. Once you get through that learning curve and understand it, you feel like a wizard. And I think it's one of those things that it's popular because it's popular. Everybody hears Google plus everybody's using it and think, well, it must be good. So let me be the first to declare, the emperor has no clothes. This is a pretty poor framework. I don't recommend it. and it's being rewritten. It's effectively end of life. A couple years, anything you write in Angular, you'll probably have to rewrite it. Bottom line, if you have a choice of frameworks right now and you're considering Angular, I strongly recommend that you avoid it. And that is my 3-part review on AngularJS. Thank you very much for joining me, and I will catch you next time.